Have you ever talked to your phone's voice assistant and just stopped and wondered, how on earth does it actually get what I'm saying? It feels like straight up magic, right? But it's not. Today we're going to pull back the curtain on the fascinating puzzle of how computers make sense of our messy, complicated, and often beautiful human language.
To kick things off, check out this classic joke from Groucho Marx. One morning I shot an elephant in my pajamas. How he got in my pajamas, I don't know. Now, as a human, you get it instantly. The whole joke hinges on that hilarious confusion about who's actually wearing the pajamas.
So, here's the big question. Why is that so simple for us, but a complete nightmare for a machine? The answer gets right to the heart of the challenge. Our language is just packed with context, double meanings, and this shared understanding that we all take for granted. Computers, well, they don't have that, naturally.
To even start to solve this puzzle, we first have to appreciate just how tricky our language is from a machine's point of view. It's not neat and tidy. It is wonderfully, beautifully messy.
You see, computers thrive on structure. Think about a perfectly organized spreadsheet, everything in neat rows and columns, all clearly labeled. It's predictable. Human language, on the other hand, is completely unstructured. It's this gorgeous chaos of sentences, jokes, and metaphors, all kind of held together by the loosey-goosey rules of grammar.
So how do we bridge this huge gap? Well, let's start with something we've all used, a chatbot. Peeling back the layers of how a chatbot thinks is, I think, the perfect way to start understanding this whole technology. Chatbots basically come in two main flavors. You've got your rule-based ones, which are kind of like a simple flowchart. If you say X, they're programmed to respond with Y. They're super rigid and get confused easily. And then you have AI-powered chatbots. These use machine learning to understand and adapt. They're way more flexible, but also, a lot more complex to build.
Now, for an AI chatbot to be actually helpful, it can't just process words. It has to figure out our goal. What do we want? To do this, it breaks down our requests into two key components.
The first piece is the intent. The easiest way to think about this is as the verb of your request. It's the action you want to take. So if you ask a restaurant's chatbot, "What time do you open?" your intent is to inquire about operating hours. The second piece is the entity. If intent is the verb, the entity is the noun. It's the specific detail that gives your intent context. So if you ask, "What are the hours for the Bangalore office?" the intent is still the same. You want the hours, but the entity is Bangalore. The chatbot needs both to give you a useful answer.
Okay, so how does a machine find these intents and entities hidden inside our normal sentences? This is where the real magic happens. Let's take a look at the secret recipe. It's called natural language processing, or NLP. So what is NLP? Just think of it as the ultimate translator. It's the field of AI that acts as a bridge between us and machines. It allows computers, which think in cold, hard data, to understand our messy, human way of communicating.
Now, NLP isn't just one thing. It's a multi-step process, kind of like following a recipe. A machine has to go through 5 distinct phases, each one building on the last, to get closer to actually understanding us. So let's break it down.
First up, lexical analysis. This is where the machine chops a sentence into its most basic ingredients. The individual words are what we call tokens. It's just breaking it down into manageable, bite-sized pieces.
Next is syntactic analysis. This is basically a grammar check. The machine looks at the order of those tokens to understand the sentence's structure. It's figuring out that the cat is the subject and sat is the verb. It's making sure it all makes grammatical sense.
Once the grammar checks out, we move to semantic analysis. This is where the machine starts to figure out the literal meaning. It connects cat to the idea of an animal, sat to an action, and mat to an object. So the basic meaning becomes clear. An animal did something on a thing.
Now this is where things get really, really interesting. Step 4 is discourse integration. This is all about context. If the sentence right before was, "It was raining outside," the machine can now infer that the cat is probably inside, sitting on the mat. All of a sudden, context adds a whole new layer of meaning.
And finally, we have pragmatic analysis. This step is all about understanding the real-world purpose. Why is somebody saying this? Are they just describing a scene? Is it a warning? It's about getting beyond what is said to understand why it was said.
I know, this 5-step process might sound a little abstract, but you interact with the results every single day.
Let's look at how this technology is already showing up in the tools you use all the time.
Seriously, every time you ask Siri or Alexa for the weather, that's NLP. When your email magically filters out spam, that's NLP. When you're shopping online and see an analysis of product reviews, or when you get an automatic summary of a long article, or use a real-time translator. Yep, all NLP.
So here's the key takeaway. NLP isn't some far-off futuristic concept. It is the invisible, powerful engine running behind the scenes of our digital lives, and it is fundamentally changing how we interact with technology.
Which brings us to a final, pretty big question. We started out by asking how machines could possibly understand us, but now, as they're getting better and better at mastering our language, maybe the more important question is, what should we ask them to help us solve next?